we are going to learn about scope of variables, right? And this is very, very important topic when you are doing the programming. So you should know about the scope of the variables. So we have two type of scopes. First is local scope and another is global scope. And another topic we will be covering is anonymous function. So what is this? Learning by doing.
Learning by doing.
Yeah, so whatever concepts I'm teaching to you over here, so you will be implementing, then you will be able to understand how this concept works. Okay, so whenever we are learning about the scope of the variables, so we will be starting with the namespaces in Python. So we will begin with the namespaces in Python, then we will be moving towards the scope of the variables, and then we will be using the anonymous functions, in which we'll be covering the Lambda function. Let's talk about this namespace in Python. This is the very important topic over here that you should be able to understand it very minutely. What is namespace? So as we can see, we can divide this term into two parts. First is we can say Python name, and then we have a term space. So let's see what we mean by Python name and space. So let's explore this further very fastly. The division of the word itself gives little more information that it's name, right? And what do you mean by name? Which means an unique identifier, right? This is a unique identifier. This is a unique identifier. And another term is space, which talks something related to the scope. So we have two terms. We will be discussing about two things, right? So no doubt we will be talking about scope over here. So this space basically refers to the scope. So what is this name? Name might be of any Python method or variable, right? So we have already seen identifiers. So corresponding identifier is basically the name you have given to the variable. Identifier basically name you have given to the Python method or function. And space, it depends upon the location where it is trying to access the variable or a method. So basically where it is being finding the location for accessing it. So let's explore Python name. A Python name is an identifier, right? Python name is an identifier. So whenever we are talking about name, so if I talk about Prem Sankran or Menaka or Amritpal, Digjit or Amanpreet, so they are identifiers. I am identifying you with something. Okay? So Python name is an identifier. If you are keeping some name, right here example we have taken some variable is there, identifier is rank. So a Python name is an identifier, something we use to access Python object, right? So this is Python object, and we are accessing this one with the name rank, right? So this is your identifier and this is your Python object, right? And in Python, everything is an object. So let's take an example. We have taken a variable rank and we have assigned the value as 1. So rank is the name associated with the Python object 1, right? So to get this object's address in RAM, basically we are storing this 1 into the memory. We are storing rank into the memory. So we need to find which address has been allocated to store it in the RAM. So then we have a inbuilt Python function ID to find the address. So what we are doing is we are passing the name of the variable to this ID function. So it is giving you the memory address. Then ID 1. So this is the object we have passed over here. So when we are trying to find the address of this, right, where object's address in the RAM, so it is giving the same, you can see. same address has been returned for rank, same address it has been returned for 1. So to take a slightly more complex example, uh, first you can see over here that we have declared one variable a and we have assigned the value 2 to variable a. Then this is the first example in which you are trying to find the object's address in the memory. So it gives you this memory address. Then what you have done is you have incremented this a with 1, and then you try to find the value of the object address a. So here it is different, right? Then you assigned new variable b and you have assigned value 2 to it. You try to find the object address of b. So you can see over here this address is same with this address. So then you try to find the object address for 2. So this is again same with a and b. Now here the value, initially the value of a was 2. Now when you have incremented, this becomes 3. Now you are trying to find the value corresponding to 3. So here you can see this value is the same with this value, right? So again I am repeating. First we have taken one variable a, we have assigned the value 2, we try to find the address of a. Then we incremented the value of a, it becomes 3. Then you try to find it, it is giving different address to you. Then you assigned a variable b, you give the value, you assign the value as 2, you try to find the address for b, it is same as that of this first one. Then you try to find the address directly for 2, it is same along with b and the initial value of a. Then you try to find for 3, it is similar with the new value of a. Actually we see why it is happening and what's happening behind. So here you can see we assigned the value 2 to the variable a. Fine. So this was our first statement. What happened? The 2 has been assigned to the variable a. So it means if you try to find the object address of a and object address of 2, right? So object address of a and object address of b, if you type id of a or id of 2, it will give you this value. Now what you have done, you have incremented the value of a with 1, it becomes 3. Now you try to find the value of a, id a, id 3. So now both will give you this value. Fine. Now you have assigned 2 to variable b. It is giving you the object address similar to this. Similar, not same, same to this, right? Why is it so? Because this object 2 has already been assigned this address. Now whenever this 2 will be assigned to this, it will start pointing to that. So now if you try to find id of b and id of 2, it will return you this. Now a has become 3. So 3 has been assigned this. A has been assigned this. So whenever you will be using this C, so you try to find id A, id 3. So you will be returned with this object address. So now let's explore this. As you can see, right, as you can see, when you set A to 3 and B to 2, B starts pointing to the object A once pointed to, because the value initially 2 was assigned with this object address. So now its value has been changed. Now when you assign B, so this started pointing to this location. So B starts pointing to the object A once pointed to. Isn't that quite efficient? Yes. It does not have to create another object to hold to for B. So this is dynamic name binding, which is very powerful in Python. So keep in mind the term dynamic, right? Name binding. So this is dynamic name binding. Then let's explore more. A name can hold any kind of value. It can be integer, it can be a string. Finally, since everything is an object, so are the Python functions as well. So, right. So consecutively, you can associate with them with the names. Functions can be associated with names as well. So let's see how. So ID, we know that this is the inbuilt function by the Python. So you have kept one identity over here where we have kept name, right? Some variable name identity, and you have assigned ID over here. So now in place of ID, otherwise you are using this term, right? This inbuilt function you are calling, but now you have assigned this ID to identity. You are mentioning identity too. So you're calling with same name. So here we associated the name identity with the built-in function ID. Let's see this example in which we are defining one function, say hello, open close parenthesis colon, print hello. Now you have one variable hi, and you are assigning this over here. So it will, so when you try to display this hi, it will display you hello. Then you find the type of hi. So it is class none type because it is not returning anything. Fine. So did function. So here let's see. Well, since the function does not return anything, it is not returning us anything. It is just printing hello. It is not returning. So we can get an object of the class none type, right? And of course, none is an object that indicates no value. That's why none type. Did function say hello return a value? Things would be different. If this say hello is returning something, so we can see the scenario will be different. Let's take another example. Here we have defined one function with the name func1. We are printing hi and we are returning 1 over here. So here the function is returning something, right? So now what we are doing is we are assigning this func1 to the variable func2, and you try to display this func2. So first it will display hi and then 1, and when you try to find the type of this func2 now, so earlier as it was not returning anything, so that's why it has given none type, but now it is returning you integer. So here it is returning you the type of the func2 as class int. Next, we have seen what do you mean by name, Python name. So now we are looking at the space which talks something related to scope, right? So we are coming in detail about scope. So here a name might be of any Python object. We have seen space depends upon the location from where it is trying to access a variable or a method. So we have two type of scopes. One is local, another is global. So a namespace. A namespace in Python is a collection of names. So a namespace is essentially a mapping of names to corresponding objects. Okay, let's again take the example, real life example. Now you have taken the admission in an university, right? In university, there are number of departments. Now you can consider that those departments are the namespaces, right? And inside that you can see that you have teachers with the names and all. So Department of Computer Science do have its own namespace. Department of Hospitality and Management do have its own namespace, and so on. So a namespace in Python is a collection of names. So a namespace is essentially a mapping of names to corresponding objects. At any instant, different Python namespaces can coexist completely isolated. So the isolation ensures that there are no name collisions. So as we have taken the example of university, and further we have taken the example of departments. So in departments, we can have the employee, right, whose name can be same with the name of an employee of other department, but they are not clashed, right? So their namespace is Department of Computer Science, and if we have MBA department, and if there are two Vishal employees, so Vishal of Department of Computer Science, Vishal of MBA department. So simply speaking, two namespaces in Python can have the same name without facing any problem. A namespace is implemented as Python dictionary, key value pairs, right? So this is important. How namespace is implemented in Python using the Python dictionary. So this can be helpful for your MCQs or interview questions. So when we start the interpreter, a Python namespace is created for as long as we do not exist. This holds all built-in names. It is due to this that Python functions like print or id are always available. Also, each module creates its own global namespace in Python. This is important. Its own global namespace is Python because they are accessible from everywhere. So when you call a function, a local Python namespace is created for all the names in it. Right. So we will be discussing much detailed discussion about local and global. So when we are calling a function, a local Python namespace is creating for all the names that are there in the function. So a module has a global namespace. The built-in namespace encloses this. So let's take a look at the figure that explains us. So this is the figure in which you can see this is the built-in namespace, that is you can see the superset. Then you have the modules, they have the global namespace, and inside it we have the function, those have the local namespaces. So this is super, then sub, and then sub, right? So we can have more example on this. Let's understand this namespace in simpler way through example a directly file system structure in computers. So needless to say that one can have multiple directories having a file with the same name inside of every directory, but one can get directed to the path of the file one's wishes just by specifying the absolute path of the file. So if you are providing the absolute path of the file, you will be directed to that file only, even though there are number of files with the same name in number of directories. Another real-time example you can take that the role of a namespace is like a surname, right? So we have seen the surname, right? So one might not find a single Alice in the class. If you talk about like Prem Sankran or Menka, Amanpreet, right? So all have Amritpal, all have there can be number of Prem Sankrans, number of Menkas, number of Amritpals, number of Amanpreet, number of Jagjit, right? So their surname may be different or their surname may be same. So there might be multiple Alice, but when you particularly ask for Alice Lee, Alice Clark, you are adding the surname, so there will be only one, right? There may be number of. So presently you are considering that if we are joining first name and last name, so that will be a unique combination. So that we have already discussed. First we have the built-in spaces, then we have enclosed modules that are the global namespace, and then function, then we have the local namespaces. So how many types of namespaces are there? So we have already seen that how we are dividing names and spaces. So types of namespaces. So when Python interpreter runs solely without and user defined modules, methods and classes, some functions like print and id are always present. These are built-in namespaces. So in built-in spaces, we can see that like print is coming, id is there, so they are coming in built-in namespaces. When user creates a module, a global namespace is created, and the built-in namespace encompasses, and later creation of local functions creates the local namespace. The built-in namespace encompasses global namespace, and global namespaces encompasses local namespaces. So built-in namespace, global namespace, and local namespace. This is the hierarchy. Then we are moving to a lifetime of a namespace. So as we have already discussed in the previous lectures also, that what is lifetime? We have taken the example of our life, right? So till we are alive, our lifetime is there. If we are not there, it means lifetime is gone. Similarly, if the variable is there, its life is there, it is alive. If its life is over, so it's not existing. We cannot access it. So a lifetime of a namespace depends upon the scope of the object. And if the scope of an object ends, the lifetime of that namespace comes to an end. Hence, it is not possible to access inner namespace objects from an outer namespace. So let's see the example over here. So here you can see this variable has been declared outside this function. So it is having the global namespace. Now we declared some function. So whatever the variables we have declared inside this, they are local to this function. And if you try to access outside this function at this indent level, you will not be able to access. So you have declared new variable var2 inside this sum underscore function. If you try to access it over here, so you will not be able to access, because this is local variable for this sum underscore function. So you cannot access is outside. Then you have inner function over here, nested function, in the name of this sum inner function, and you have declared some nested variable var3, right? So here var3 is accessible only to this, right? So this is local to sum underscore inner underscore func. So this is the local variable. So as shown in the following figure, same object name can be present in multiple namespaces as isolation between the same name is maintained by their namespace. So here, this is your namespace 1, this is your namespace 2, this is the namespace 3. Here you can see you have three variables, variable 1, variable 2, variable 3. So these are local to this namespace. Then here you have variable 1 and the name. Here also variable 1 is there, variable 1 is there, but they are isolated. They are not disturbing each other because this is in namespace 3. right? And these are the local to this namespace 3. And here you can see variable 4, which is there in namespace 3 as well, but this is not related to the namespace 3 variable 4 because this is isolated from here, right? So it has also 3 variables, and these 3 are local to this namespace 2. So in some cases, one might be interested in updating or processing the global variable only. So it means, suppose you want to update the variable 1 sitting at namespace 2. You can do so. We will see how can we do so. So one should mark it explicitly as, so we need to mark it explicitly as global, and then we can update or process it. So now what is Python variable scope? Though various Python namespaces, not each can be accessed from every part of the program. A namespace is in variable scope in a part of a program if it lets you access the Python namespace without having to use a prefix. So any instant of time, we have at least 3 nested Python scopes: grunts, function variable scope, local names; module variable scope, global names; outermost variable scope, built-in names. So we have already seen 3 type of in this way, right? So this built-in comes at the outer portion, global comes at the middle portion, local names comes innermost. So then this in accordance with 3 kind of namespaces in the Python. So we had already discussed. This also decides the order of searching for when a reference is made. So when you are trying to access some variable, so there is an order of searching. The order is, first it will try to find from the innermost portion. It will try to find from local, then global, then built-in, right? Also, a nested function creates nested variable scope inside the outer functions scope. So if you can see over here, so this is your nested function. So this is the nested scope. So it will start from here, then it will go to here. Then does variable scope refers to the coding area where a particular Python variable is accessible. So this is your full code, right? So this is your coding area. This is whole coding area, right? So this is, you can say, this is one coding area, right? This is your another coding area, and outer, this is your third coding area. So where your variable is accessible. Variable scope refers to the coding area where a particular Python variable is accessible. Hence, one cannot access any particular variable from anywhere from the code. So recall that a variable is a label for a location in memory. We have taken the example when I have taught you variable. I have told you take the example of colony in which we have the houses and we have the house numbers, right? So not all variables are accessible, and not all variables exist for the same amount of time because each variable has its own lifetime. So let's start with the local variables. A variable that is declared inside a function or a loop is called a local variable, right? So let's see the example over here. You have a function sum in which you have 2 variables, a and b, and third variable is sum. So these a, b, sum, these 3 are local variables for the sum function. So they cannot be accessed outside. Here you can see def and print are at the same indentation level, right? You are trying to access this variable a over here, but the lifetime of this variable was only within this function. So this function, this variable is not visible for outside world of the function sum. So this will give you an error. So in case of functions, when you define a variable within the function, its scopes lies within the function only. And when you have come out of the function and you try to access it, so it will give you error. It is accessible from the point where it is defined until the end of the function. From the point, right, from the point until the end. So only this is the scope and lifetime of this variable a, sum, b, and sum. It will exist for as long as the function is executing. And when it is coming out of the function, its lifetime is gone. Local variables cannot be accessed outside the function. The parameter names in the function, they behave like a local variable. Parameter names means, suppose you have defined the function sum, find sum a comma b, right? So this a and b, they are local to this function only. And global variables, a global variable is easier to understand. It is not declared inside the function and can be accessed anywhere within the program because it is global. Now here I give you an example of warranty. Whenever you are purchasing some item, some has local warranty, some has global warranty. Global warranty means you can go out of your city, out of your country, you can access the warranty over there. So this is global warranty. Local warranty means that only in Patiala you can have, or in Punjab you can have, or in other states, some of the states. So they are local to that part only. Right. So a global variable is easier to understand. It is not declared inside the function and can be accessed anywhere within the program. It can also be defined as a variable defined in the main body of the program. So if it is so, then any function or loop can access it. And its scope is anywhere within the program. So here, look at the example. We have declared this global variable because it is outside the function. And when you try to access this a inside this function, it is accessible and you are able to print it. Fine. So this a being the global variable is accessible inside the function as well. So what if we want to modify the global variable inside the function? Right. Now you want to modify the global variable inside the function. So for that purpose, you need to use the keyword global. So the global keyword allows us to modify the global variable. It is used to create a global variable and make changes to the variable in the local scope. This is important. Making changes to the variable in the local scope. So here you can see that we have a global variable a. We have assigned value 1 to it. You are defining one function. Now you want to modify the value of this global variable. You are writing the keyword global in front of it. Global a equal to 2. Then you are changing, incrementing to 1. It is displaying the value of a. So now it will printing a equal to 3 because it has been modified over here. And when you have incremented it, it has been incremented to 3. So rules for using the global keyword, that is also important. If we have assigned a value to a variable within the function body, right, it would be local unless explicitly declared as global. So if you are, suppose, defining some function sum, right, and you are using a and b, right, so these are local to it. But if you are writing global in front of this, so now these variables are not local, they become the global. Those variables that are referenced only inside a function are implicitly global. So in here in the previous example, it was referenced. There is no need to use global keywords outside a function because it is always accessible. So we need not to use the global keyword. How does the scope changes when we have nested function? When we define a function inside another function, it becomes a nested function. So we have already seen one nested function over here. So this is your outer function, and this is your inner function, which is nested inside sum underscore func. Right. So we already have seen how to access a global variable from a function by using a global keyword. Now, when we declared a local variable in a function, its scope is usually restricted to that function alone. This is because each function and subfunction stores its variables in separate workspace. Right. So let's go back again. So all the variables, right? All the variables that are related to this sum underscore func, they will be having their own namespace, and all the variables of this inner function sum underscore in and inner underscore func, they have their own namespace. So namespace 1, namespace 2, right? So then when we declared we have seen, and then we have a nested function also has its own workspace, but it can be accessed to the workspace of all the functions in which it is nested. Means a variable whose value is assigned by the primary function can be read and overwritten by a function nested at any level within the primary. Right. So what do you mean by that? Coming back to the nested function. So here you can see this variable 2 is basically a global variable for this inner function. But this variable 3 is not accessible to this variable 3 is not accessible to this outer function. Fine. So inner functions can access all the variables of its outer functions, but outer functions cannot access all the variables of their nested functions. So here you can see example. One is your outer function, then we have the inner function, right? So here inner function could read the variable x, because x is basically global for this inner function, right, which is non-local to it. And if we must modify x, we declared it's non-local to the inner. And if inner function wants to modify this x, it needs to declare global x. You need use the word global. So here you can see this is a global variable we have declared. Then we have function 1, inner function, nested function. This is local to func1, but global to func2. This is local to func2, not accessible for func1 outer. So in this code, A is in the global namespace in Python, B is in the local namespace of func1, and C in the nested namespace of the func2. So here you can now look at this. C is local in func2. C is local. B is non-local, and we can say global to func2. And A is global for all. So by non-local, we mean it is not global, but it is not local either. Of course, here you can write C, read both B and C, but you can't access A. That would create a new local variable A. So this is another example. This is the global variable, then B inside func1, then we have A2, B3. So these are, local to func3, although they have the same name, but this is the local and separate namespace. So here you are trying to print the values of A, B, and C sitting in func3, right? So it will display 2, right, 3, and 3, because order of searching is local, global, inbuilt. So if it is finding it locally, you will display locally. So it is displaying 2, 3, and 3. Then you call the function f function 3. So here it will display b equal to 2, right? So here we are declaring b equal to 2 because it has taken from here, it is the local one, right? You try to find the value of a, so as you have used a2 over here also, but when you try to independently, so it will display 1. So another example, to deal with this situation, we use the terms global and non-local, right? So one is global, another is non-local. So this is one example, right? And then this is local to B. Here now what you have done, you have global A. So here you are modifying this, accessing this, and now this has been replaced with 2. This is known local, right? And b equal to 3, c equal to 3. So now you can see here that first it has taken a equal to 2 from here, right? Then b equal to 3 from here, c equal to 3 from here. When this func3 is called, right, it has displayed this. Then when this is being called, here b equal to, initially it was b equal to 2, but now you have declared here non-local b, so now this is replaced with 3, so it has displayed 3. Here you have taken global, you have replaced with 2, now this a has become 2, so now when you are printing the value of a, it will display you 2. Then anonymous functions, Python Lambda function. Python Lambda function is known as anonymous function that is defined without a name. That's why it is anonymous function, right? Anonymous function, that's why we are defining without name. So Python allows us not to declare the function in the standard manner by using the def keyword. Rather, the anonymous functions are declared by using the lambda keyword. Here anonymous functions are used by the keyword lambda. So however, lambda functions can accept any number of arguments, but they can return only one value in the form of expression. Any numbers can be accepted as arguments, but it can return only one value for in the form of expression. So anonymous functions contain a small piece of code. So it is basically, we can say it is a kind of inline functions, but they are not exactly the inline functions. So this is again the question we have for MCQs and many questions that are covered from the MCQs. So syntax to define an anonymous function is like that. So this is the keyword that you are defining. You are mentioning the arguments over here. Then you are putting the colon and then the expression to return back. So it can accept any number of arguments, right? And has only one expression. So it is useful when the function objects are required. So let's see the example. So here you can see lambda you have used, then a colon a plus 1. This is your argument, but you are passing, and here what it is returning, right? So how to call it? So you are calling basically x. So you are printing x, right? So print sum equal to, you are calling this function x, anonymous function, and you are passing this a over here. So first you are printing x, so it is saying that it is function lambda, and when you are trying to print the value for sum, so it has called this anonymous function x, passing this 20 to a. It has calculated 20 plus 30 and return back 30. So then you can use this lambda function with filter, right? So Python built-in function filter, it accepts a function. So when you are using this filter, you are passing a function to it, right? And it will return and a list as an argument. It provides an effective way to filter out all the elements of the sequence. It returns the new sequence in which the function evaluates to true. So let's see the example. Here, this is the list that we will be passing to this filter function. Now, this is the odd list. It is the list what we are getting when we will be solving this expression, right? So you have used this filter and it is accepting two arguments, number one, and this is another argument. This second argument is basically the list that we have declared over here. And this is the anonymous function lambda, in which x is there, colon, if x mod 3 is equal to 0. Means if it is a multiple of 3, then it is filtering out. So how it is doing is, it is picking each element of this list. It will pick 10 over here and apply this lambda function 10 colon 10 percentage 3 double equal to 0. So it will check whether this is multiple of 3, this 10 is multiple of 3 or not. If it is multiple of 3, it will return back to this odd list. Otherwise, it will not include in this tuple. So the tuple contains all the items of the tuple for which the lambda function evaluates to true. So when you try to print this odd list, it will display only those elements of this list, means filtering out only those elements of the list that are divisible by 3, or only those elements that are satisfying this condition of mentioned in the lambda. So this is how the filter works. Then is map. The map function in Python accepts a function and a list. So here also you are passing two arguments over here. First is this and another is this, right? So sorry, so this is first, like this is the anonymous function as first argument, and another is you are passing list. So what you are doing is, here you are not filtering, but whatever computation or processing you have mentioned over here, it will be applicable to each element. So here it is taking 10 over here. Now 10 multiply 10 power 2, it becomes 100, right? Then it has taken 20, so 20 raised to power 2, it becomes 400. The next atom is 30, so 30 colon 30 power of 2, so it becomes 900. 40 power of 2, right? 1600. Then 50 power of 2, then 60 power of 2. So it is doing some processing or modifying the elements of the list, whatever way you have mentioned. So this is mapping. So the tuple contains all the items of the list after modification. In the case of this was filtering out, it is after modification, it is including each and every item of the list. So this is some global variable. So these are the websites we have used for taking the content of this presentation. So this is whatever I have taught you today, you will be implementing in Python interpreter, and then you will be able to understand how everything is working. Okay, thank you very much.